This is the screencast for section 3.3, example 1. Miss Larson, do I keep having to use the limit as x approaches h of f of x plus h minus f of x all over h? Do I have to write every step? Are we going to do this all the time? This is really tedious. These problems are so long. These take me forever. Well, guess what? We are finally going to learn shortcuts. So here we are. We have 4 rules we're going to learn in this example to shorten your lives in terms of taking derivatives. How exciting. First of all, rule number 1, the derivative of a constant function. So in other words, if you have y equals 5, the derivative of that constant is 0. So y prime would equal 0. Rule number 2, the power rule for positive integers, powers of x. If n is a positive integer, then the derivative of x to that positive integer, you put the integer down in front as a multiplier, coefficient, and then subtract 1 from the exponent. So for example, y equals x to the 4th, the derivative, so dy dx, another way of writing y prime, would be 4x cubed. So 4 came down in front, and then x to the 4 minus 1 is now 3. The constant multiple rule. If u is a differentiable function of x and c is a constant, then the derivative of this constant times a function is, you can take the constant and put it on the outside. So if I start out with y equals 5x, 5 is my c value, my multiplier. So then I'll take dy dx equals, put 5 on the outside, and now I'm only taking the derivative of x. Well, let's see here. The derivative of x. X is to the first power. So I'll take that first power, put it down as a coefficient, and now I have x to the 0, which is just 1. So 5 times 1 is 5. Or maybe a better example for that would be over here. Y equals 5x squared. I'll take y prime equals, we'll put the coefficient on the outside, 5, and then times the derivative of x squared. And from the exponent rule, the power rule, we'll say that the derivative of x squared is 2x now to the first, so in total, 10x. Now the sum and difference rule is great in that it lets us use each of these rules independently on terms that are being added or subtracted. So we're going to use the sum and difference rule in combination with the other 3 we just learned for example 1, and then now try problem number 5. Alright, so for example 1, differentiating a polynomial. Find dp dt if p equals. So dp dt. Now you could write p prime, but this specifically says find dp dt, so we need to write it as dp dt. I can use the power rule on t cubed, and then I can use it separately on 6t squared, and then 5/3 t, etc. because of the sum and difference rule. It lets me basically distribute the derivative over addition and subtraction. So this will be 3 times t to the 3 minus 1, and then 6 I'll leave on the outside, but now this is 2t to the 2 minus 1, minus 5/3 will stay on the outside, and then I'll see t to the first, so that's going to be t to the 1 minus 1, which will be 0, plus, now this one we said the derivative of a constant is 0. So I have 3t squared plus 12t to the first minus 5t to the 0, and then plus 0, which I don't need to write. So really, I just have 3t squared plus 12t minus 5. Now you will get very good at being able to do this in one step, but for the purpose of notes, I'm going to show you every single little detail so you understand how I'm using the rules. Number 5, the now try problem. Sometimes, a lot of times, when we're taking derivatives, it'll be easier to do a little bit of algebra first to make it set up in a way that's going to make the derivative easy. So for example, x cubed over 3 is weird. I only know how to take the derivative when I have a coefficient in front of x with a power. So I'm going to rewrite y, I'm not taking the derivative yet, as 1/3 x cubed and then plus 1/2 x squared plus x. Now I will show you how to do this simply like I would expect on homework. Y equals 3 times 1/3 x squared plus 2 times 1/2 x to the first, and then plus the derivative of x is 1. So y equals x squared plus x plus 1.